Hello and welcome to this short video on a particular type of supernova. I'm sure you all know a bit of what a supernova is. One of the requirements of a supernova is that it has at least 10 solar masses. One solar mass is the mass of our Sun. A normal supernova will occur approximately every 60 to 100 years, depending on which bit of literature you're reading. However, as I said a bit earlier, this is a short video on a particular type of supernova, and the name of that supernova is called simply a failed supernova. A failed supernova starts out in the early stages as a normal supernova. In other words, there is a core collapse. The core collapsing produces a neutrino surge. These neutrinos will cause shock waves in the outer layers of the star. Those shock waves will cause the outer layers to blow off in a large explosion. However, in a failed supernova, only a small proportion of the outer layer is blown off, and that is because there are not enough neutrinos produced by the core collapse. Exactly how much of the outer layer is blown off we'll cover in a few seconds. A key point with the failed supernova is that the core collapse will cause a black hole. The work described in this video was done by a research group led by Kishalay Day, DE. His group looked at a particular star over a number of years, and eventually, when it did go supernova, except it wasn't a normal supernova, they deemed it to have been a failed supernova. The link to their paper is below. The paper is by, as I said, Kishalay Day, and its citation is normally along the lines of Day et al. So what was this star the team were looking at? Well, it was a star in Andromeda, and the name of the star, well, it's not so much a name, it's more a designation. It's M31-2014-DS1. The star was observed between the years 2014 and 2022. And it is that work that led to the paper earlier this year in 2026. So what were the particular indicators that made the research team decide that this was a failed supernova and not a normal supernova? There were two primary indicators. The first indicator is that there was a brightening in the infrared spectrum. The second indicator was that the bolometric luminosity of this star, DS1, stayed almost constant. The bolometric luminosity is defined as the total energy given out, well, electromagnetic energy given out by the star. In other words, across all wavelengths. The second indicator was that after about 100 days, This luminosity, the bolometric luminosity, fell by a factor of 10. So those are the two indicators which allowed the team to determine that this was a failed supernova and not a normal supernova. Now, earlier on, I pondered the question, how much of the outer layers were actually given off? Well, the team found that 98% of the outer layers fell back onto the core, and it's that extra volume, or mass should I say, that extra mass which causes the core to implode and produce a black hole. What follows this short video section is a simulation. The simulation shows how the failed supernova progresses. At each stage of the simulation, you'll see a heading at the top of the screen. So this will tell you where we are in the cycle. Now again, this is also a very short simulation. So at this point, I will say thank you for watching. I hope you've learned something, and please subscribe. Thank you.